Ettore Majorana. You find a short, folded note in an old desk drawer, and the handwriting chills you because it reads like someone packing up a life and walking away. He was a prodigy who walked into physics like it was a small room he already knew. He solved problems others could not touch. He worked with the brightest group in Italy, and he vanished after a ferry crossing. On March 25, 1938, he boarded a ship from Palermo to Naples, and he never reached home. No body, no final sighting. Just a few cryptic letters and a single ticket stub. You know the story version. Suicide, self-exile. Maybe a new identity in South America. Those are the sensible explanations. They fit the paperwork and the voices that mattered at the time. But here is what makes the rumor mill never stop. A brilliant mind disappears with no trace, and the gap between facts and fantasy quickly fills with stories. Here is what is really happening in the physics that people latch onto when they start to whisper about impossible things. Certain solutions to Einstein's equations let time behave in strange loops. Famous thinkers showed mathematically that closed loops through time can exist in theory. That does not mean someone built a machine in a seaside town in the 1930s. It just means that the math allows weird possibilities under extreme conditions. So why does the time travel whisper stick to this case? The disappearances of geniuses invite supernatural explanations. Add a few misread notes and a dramatic personality, and the public imagination stitches a narrative where science and secret knowledge collide. People want a hero who escaped more than they want an explanation that leaves no mystery. There is one witness report that does not fit the neat narratives, and it involves a single passenger who reported a conversation that sounded like more than a goodbye. That small, odd detail is what turns a probable vanishing into a story that will not stay quiet. There was a slim file of letters that people study the way others study fingerprints. One reads like a goodbye, another is practical, asking for a small cupboard to be kept in his name. A third is dry and oddly everyday, like someone trying to make a clean exit without drama. Historians piece those notes together and build the simplest picture. He was troubled, he withdrew, he may have wanted to vanish, but there is also the technical thread that feeds the wilder stories. He had been thinking about symmetry in particles, about objects that might behave like their own mirror. That kind of work sits at the edge of what we can test. It invites phrases like strange solutions and strange particles. When a mind that lives on edge of the unknown disappears, the public quickly supplies the rest. If your work touches on the edges of reality, people prefer a secret breakthrough to a quiet retreat. Here is the factual payoff everyone wants. The official inquiry never proved foul play. No body was ever recovered. Investigators followed leads to ports and to small towns and to mythic South American routes. They found nothing conclusive. That absence of proof is what gives the rumor engine fuel. It is easier to imagine dramatic endings than boring ones. Now consider why time travel whispers attach themselves to this silence. The math of relativity and later work in theoretical physics show that, under extreme conditions, time can loop back. Some equations permit closed loops in time. Mathematicians and physicists scribble proofs, and then add careful notes about physical plausibility. That careful language rarely survives the leap from a research paper to a late-night internet forum. The result is a ripple. A vanished genius plus exotic equations equals a tidy myth. So, what should you believe when you read the late-night headline that proclaims a secret machine or a vanished traveler? Start with the records. Most of the threads point to choice or tragedy, not to a laboratory door that opened into yesterday. But the one passenger who claimed the conversation sounded like a plan remains unexplained. The seat on the ferry stayed empty. Nikola Tesla. You grew up hearing the wildest lines about him, the lone genius who talked to the future. He built coils and sparks and made lights dance without wires. He patented machines and claimed ideas that sounded like magic. In his notebooks, he wrote about radiant energy and theoretical beams that would stun armies. Newspapers loved the drama. Investors loved the promise. He loved the attention, and then he hated it. By the end of his life, he was living alone in a hotel room in New York. He died peacefully of a heart condition in room 3327 of the New Yorker Hotel on January 7, 1943. Still, the story refuses to be simple. Rumors say government agents seized secret papers. Rumors say his work was stolen. Rumors say he disappeared into a hidden experiment. The reason those rumors never die is simple. A brilliant inventor plus government interest equals a conspiracy of shortcuts. People fill the empty spaces with bigger stories. It is tidy and it sells. Here is the factual part that matters. His real experiments touched electromagnetism and high-frequency currents. Those are powerful fields that interact with matter in strange ways. None of his surviving patents or lab notes show a plan for temporal displacement. After his death, officials did take some papers for review. Later, many documents were returned or archived. There is no credible evidence a working time machine was in those boxes. Why then does the time travel whisper cling to his name? Because he spoke poetically about time, because he seemed to see ahead, because his later years were eccentric and poorly understood. Those three things together make a perfect seed for legend. People conflate poetic language with technical blueprints. Enthusiasts point to a sentence. Bloggers inflate a paragraph. A rumor becomes a recurring echo. So, when you hear a late-night claim that he built a device and walked into tomorrow, check the records first. The real story is human and messy. The myth is tidy and thrilling. The hotel room keys were found on his body, and the lights kept flickering long after the lamp was switched off. His papers were boxed and examined. Officials from the Office of Alien Property cataloged notebooks and papers. Some items stayed in government custody for a time. Other items were later returned to museums and archives. That sequence fed two powerful stories. One story is simple. A troubled genius falls into poverty and dies alone. The other story is louder. A government takes secret papers and hides them. Both stories are true in parts. The first is documented. The second grows when context is missing. A clear fact to hold on to is this. No surviving patent or laboratory note shows a blueprint for a device that moves a person through time. His experiments dealt with high-frequency currents and with wireless transmission of power. Those are real, and they are complicated. They are not time machines. Enthusiasts point to poetic sentences in his notebooks and treat them like technical instructions. That leap is the engine of the myth. Then there is the human angle that keeps the legend alive. He fed the media with dramatic claims. He fed pigeons in a park, and he spoke about the future as if it were a room he could walk into. People remember the poetry more than the math. When later a file is vague or redacted, the memory rushes in to fill the blank. That is how tidy conspiracies are built. So what should you take away from his life and from the rumors that surround it? Respect the real achievements. Question the sensational leaps. And when someone tells you police seized a secret device, ask to see the catalog. The catalog tells the story more honestly than a late-night headline. The light in his hotel room went dark, and the record keeps the rest. Kurt Gödel. You flip a page in an old journal, and suddenly time feels less like a river and more like a loop. He was not a showman. He was a thinker who trusted symbols and logic. In 1949, he found a solution to Einstein's equations that changed how people could talk about time. His model described a rotating universe where paths through space-time could curve back and meet themselves. In plain terms, that means, at least on paper, it is possible to draw a route through the cosmos that returns you to the moment you started. Mathematicians call those routes closed timelike curves. The words sound technical. The picture is simple. Imagine walking a path that circles until your footprints land back where you began. But this time, the date on the calendar has moved backward. Here is the careful part. Gödel's solution is a mathematical reality. It is not a travel brochure. The geometry he described requires a universe that rotates in a way our observations do not support. Einstein read Gödel and felt unsettled. He respected the math and worried about its physical meaning. Later, physicists added cautionary notes. Stephen Hawking would call for chronology protection and point out that the laws we know likely close dangerous loops. Why does this matter to people who adore time travel myths? Because precise math gives myths a believable doorway. A headline can shorten a long line of careful caveats into the claim that a scientist proved time travel exists. That is how a subtle proof migrates from journals into late-night forums. So, what do you hold on to when the math gets weird? Hold the difference between what equations allow and what the universe shows. Gödel opened a conceptual door. He did not step through it, and that question still wakes people at 2 a.m. He stood the problem on its head. The neatest answer offered by serious thinkers is a rule that says events must fit together. If a loop exists, then what happens inside the loop must match what already happened outside. That makes some paradoxes vanish on paper. It does not make them easy to accept in the kitchen or the courtroom. Other scientists replied with caution. Some said the math is a map, not the territory. Some argued quantum effects will spoil neat classical loops. Stephen Hawking later offered a rule of his own. He suggested the universe might have a built-in safety net that forbids practical time travel. That safety net idea gives a clear headline. It also reminds us that equations often need more than algebra. They need physical conditions we can test. Here is a small, shareable fact. The equations that allow time loops require matter and motion that we simply do not see in our universe. That is why most cosmologists file this kind of solution under interesting thought experiments. They teach us what is logically possible, even if it is not physically likely. So where does belief end and evidence begin? You hold math and observation side by side. When the math allows a thing and the sky does not show it, you favor the sky. Still, the tension remains delicious. A neat proof plus human imagination births endless stories. That is how scientific possibility becomes midnight rumor. What matters most is this. The proof did not build a machine. It opened a question about reality itself. The page closes, and the room grows quiet. John Archibald Wheeler. He walks into a lecture hall and writes 2 short words on the blackboard. The room hushes. Those 2 words change how people imagine the universe. Wheeler helped turn strange equations into names people can say. He popularized the phrase black hole. He helped bring wormholes out of dusty notebooks and into public discussion. He saw space-time as something you could shape, fold, and question. That is part science and part imagination. Here is the simple picture. A wormhole is like a tunnel carved through the fabric of space. Enter one end, and you might exit far away or at a different time. The math that describes such tunnels comes from Einstein's field equations. Wheeler and others explored what those solutions might mean. They showed how mass, rotation, and energy can twist space-time in surprising ways. They also showed the catch. To hold a traversable tunnel open, you need forms of energy we have not found. That makes practical travel unlikely with the physics we know. Wheeler also taught a generation of physicists to ask bolder questions. He called space-time geometry a language for physics. He was both playful and rigorous. He gave science vivid metaphors, and then pushed students to make careful checks. His influence is everywhere. The phrase black hole is a shareable hook. The phrase wormhole is a better story starter than most equations. Scientists today treat wormholes as intriguing thought experiments. They test the limits of general relativity and quantum theory. Some hope new discoveries will change the math. Others expect the universe to protect its own history. So ask yourself this simple question. Do you trust a clever phrase to mean something real in nature? Or do you hold to the measurements of the sky? The chalk fades under Wheeler's hand, and the lecture hall is suddenly too quiet. Wheeler left us with a problem that sounds like a construction project. If you want to tunnel through space, you need a frame to hold it open. In the math, that frame behaves like a strange kind of scaffolding. Physicists call the stuff exotic matter. It would have negative energy. We do not have a way to gather that material. We do not know if it exists in any useful amount. That is the practical hang-up. Then there is stability. Even if you could open a throat through space-time, it would collapse the moment you try to pass. The equations show violent instabilities. In many models, the tunnel pinches shut or blows itself apart. The dream of stepping through and arriving in another century runs into simple mechanical trouble. Meanwhile, the universe gave us black holes we can actually see. Telescopes and detectors made once speculative objects concrete. In 2015, observatories detected gravitational waves from two merging black holes. In 2019, a global array took a picture of the shadow of a black hole. Those moments turned words into data. They also taught a humble lesson. Bold ideas can survive when they meet measurement. Wormholes remain an elegant possibility on paper. The sky does not yet point to them. So what do we keep from Wheeler? We keep the courage to name strange things and the discipline to test them. We keep the metaphors because they help us think. And we keep a patient doubt because the universe often says no before it says yes. The chalk is dusty. The lecture hall empties. The blackboard still holds the ghost of a drawing that looks like a tunnel disappearing into night. Igor Novikov. You hold a simple act in your hands and wonder if history will let you do it. A rule says some things cannot change. If a loop in time existed, then any action inside that loop would have to match what already happened. Picture a page in a ledger. You try to write a different entry. The ledger wrinkles, and the ink refuses to dry. The self-consistency idea says history is not a scrapbook you can rearrange. It is more like a woven cloth. Pull one thread, and other threads pull back. Here is a quick example everyone remembers. The grandfather problem. If you go back and stop the person who becomes your grandparent, then you erase the chain that led to your existence. The rule says such contradictions cannot occur. If you try something that would cancel your existence, the universe forbids it in some way. That is one way to solve the paradox without inventing extra worlds. Scientists like the rule because it preserves logic. It keeps cause and effect from degenerating into nonsense. Philosophers dislike it a little because it seems to squeeze free will into a pre-existing story. Some researchers try to reconcile both views. Others prefer the many worlds answer, where every conflicting choice spawns a new branch. The debate is lively, and it is not settled by experiment. What should worry you is this. A tidy mathematical escape does not mean a machine exists. It means our equations can be consistent even when they allow weird loops. The more interesting question is practical. If the universe forces consistency, then who or what enforces it? Is there a law that polices paradox, or do events conspire on their own? Think about a movie where a character tries to change a past event, and the film finds a clever way to patch the plot. In real physics, the clever patch is a rule. The rule says events must line up. If you act inside a loop, you cannot create a contradiction. That is the point. It keeps cause and effect from unraveling. Many physicists find the rule elegant. It preserves logic without inventing parallel worlds. Other physicists dislike it because it feels like a constraint on freedom. Some prefer the idea that every choice makes a new branch of reality. The two responses are not just technical, they are philosophical. They touch on free will and responsibility. There is also an important practical point. These ideas are models. They are mathematical frameworks that help us think. We do not yet have an experiment that forces a loop and shows the rule in action. No lab has ever produced a closed timelike curve for people to test. That absence keeps the conversation honest. It also keeps the rumor engine running. Here is a useful line to remember. A theoretical escape from paradox does not prove a machine exists. It proves that our math can be self-consistent under odd conditions. That fact is both powerful and small. It gives us permission to imagine, and it gives us a reason to demand evidence. So, where does that leave you when you read a sensational claim? Ask if the claim shows data or only equations. Ask who tested the proposal and what the sky says. The ledger might refuse the ink. The room goes quiet. Ronald Mallett. You see a young man in a classroom promising himself he will find a way back to a lost afternoon. His work began as grief and became equations. He asked if light, moving in a circle, could drag space-time enough to make a small loop in time. Think of light as a fast river. If you race a river in a circle, you twist the water around a rock. In general, relativity, energy, and motion can twist space-time in a similar way. He wrote a paper that describes how a circulating beam of light might create those twists. Here is the plain recap. His math showed that, in theory, circulating energy produces frame dragging. Under extreme, ideal conditions, the equations admit closed paths. The paper did not build a machine. It sketched a possibility and called out the enormous physical hurdles. The critiques are important. Many physicists pointed out idealized assumptions. Some calculations assume an infinitely long beam or ignore quantum effects. The energy required to get a practical loop is astronomically high. Others worry about hidden singularities and the chronology protection idea that prevents paradoxes. Most experts treat the proposal as speculative but interesting. Public reaction turned his careful paper into a hopeful headline. He wrote a book and gave interviews. People loved the human angle. They turned equations into destiny. That is how modern myth grows. A living scientist who speaks about time travel becomes a ripe target for rumor. So, what do you take from his story? Do you see a brave mind pushing a border, or a public hunger turning math into myth? What is the difference between a paper on a blackboard and a claim that someone found a door in the world? The math was careful. The assumptions were not. A circulating beam in an idealized model produces frame dragging on paper. The real problem is twofold. First, you need energy densities that are off the charts. The numbers in the calculations climb into ranges our machines cannot touch. Second, the solutions often rely on ideal conditions that disappear when you add real-world effects like quantum noise. In plain words, the suggestion is interesting. It is not a plan you could build tomorrow. Critics pointed these things out in journals and in conferences. They also noted that certain technical steps in the paper assume simplifications that make the math neat. Real physical systems refuse neatness. That does not mean the idea is worthless. It means the gap between a theoretical proposal and a functioning device is enormous. Then something familiar happens. A human story arrives. The scientist had a personal reason. He wrote a book that mixed memoir and science. He gave interviews that the public found moving. Reporters turned equations into headlines. Online communities took the hope and ran. The result is modern myth-making. A living researcher who speaks emotionally about time becomes the seed for rumors that outpace his actual work. So, when you see a viral claim that a laboratory found time travel, ask for details. Ask what was measured. Ask who reproduced the result. Equations are powerful. Experiments are the final arbiter. Picture a quiet lab at night. The lamps are low. A board holds chalked equations that might never meet metal and wire. The hall doors close, and the rumor steps out into the street. Dr. Franklin Reno. You find a thread online at 2 a.m., and the name reads like it is a key to a locked door. He is a creation of modern conspiracy. There is no paper trail in the National Archives, and no declassified memo that names him. He lives in the pages of a book and in the memory of internet posts. That matters because the most convincing legends are the ones that sound scarier when you repeat them out loud. The story around him is classic. A government base on a lonely coast, strange experiments in hidden rooms, machines that bend perception, and calendars that stop making sense. Camp Hero was a real place. It had radar towers and technicians. It did not have public records that match the extraordinary claims. The gap between a real radar station and a fictional time lab is where rumor grows roots. Why do people build characters like him? First, a named person makes a story easier to believe. Second, a scientist figure gives the tale authority. Third, the Cold War context supplies plausible secrecy. Mix those three ingredients, and you have a story that people can pass on as if it were fact. There is a useful skill here. When you hear a dramatic claim about vanished researchers, ask for the paperwork. Ask for primary sources and dates. Ask which records declassified them. Myths travel fast. Documents move slowly. That contrast tells you where to put your trust. So, when you read about a shadow scientist who opened a door in time, ask one more question. Did anyone see the door close? The wind at Camp Hero still whistles through the empty station. The origin text reads like a confession and a fevered dream stitched together. It offers interior detail in plain language. It names rooms and instruments and gives dates that sound exact. That is the first trick. Specifics make a story feel like proof. The second trick is plausible setting. Camp Hero is real. Radar towers and concrete bunkers exist. Ground truth gives the fiction a spine. Then the narrative sprinkles familiar fear. Cold War secrecy. Mind control programs that actually happened elsewhere. A few truthful precedents make the rest believable. People mix verified facts like base operations with invented corridors and strange devices. The result is a compound that looks archival, but is not. Online communities do the rest. A forum post becomes a screenshot. A screenshot becomes a clip. Collective repetition transforms a name into a memory. Eyewitness-style accounts appear years later. That is how a fictional scientist becomes a cultural reference. So, how do you sort the record from the tale? First, ask for original documents, declassified memos, personnel lists, dates in official logs. Second, check independent archives. Newspapers, military records, and local histories are blunt tools for truth. Third, demand corroboration from multiple, independent sources. A single story, however vivid, is not a substitute for documentation. Here is a short line to remember. Documents move slowly, rumors sprint. That difference tells you where to put your trust. Walk out to the old gate at Camp Hero at dusk and listen. The radar towers cast long shadows. The empty control rooms answer with echoes. The wind carries stories down the corridors, and you can almost hear a name being repeated until it sounds like history. John Titor. You are awake late, and you find a post claiming someone just stepped out of the future. The posts appeared between November 2000 and March 2001. The writer claimed to be a soldier from the year 2036. He described a machine and a mission. He said he needed an IBM 5100 from 1975 for a crucial software fix. That small technical detail gave the story a sudden weight. The IBM 5100 was real, and it did have peculiar quirks. That fact made the posts feel like insider testimony. Here is where the test gets simple. Many of the predictions did not come true. A civil conflict beginning in 2004 and a global war were forecast. Those events did not occur. The most persuasive parts of the posts are specific and verifiable. The least persuasive parts are the big future claims that failed. That pattern is classic for a hoax that uses verifiable detail to build credibility. Beyond details, there is the human element. The author wrote like someone with technical knowledge and with a knack for narrative timing. Forums amplified the posts. People copied them. Fans created edits and videos. The story became communal property. That is how a modern myth gains stamina. It needs technical hooks, a plausible voice, and a network that repeats it until it sounds familiar. So, what should you do when you read a claim that a disappeared scientist discovered time travel and then vanished? Ask for verifiable predictions. Demand replication. Look for independent evidence outside the story community. And ask who benefits from the story spreading. After all, a convincing voice in a forum can sound like proof until you check the records. You close the tab and a question stays with you. If someone came from the future and told you the date of a disaster, would you believe them without proof? The street outside is quiet, and the internet hums where the rumor lives. A few details made the posts feel real. Technical phrases, timing, and an authentic-sounding motive create an illusion of authority. The IBM 5100 reference is a perfect example. It grounded the story in hardware that actually existed. That small, true fact let readers assume the rest was trustworthy. Then, predictions failed. Big predictions did not happen, and the strongest claims evaporated. That pattern is a red flag. When a claim rests on a mix of verifiable detail and sweeping forecasts, you have to weigh both parts separately. The detailed bits can be true, while the grander picture is false. Why does the story keep breathing? Online communities are engines of repetition. A post becomes a quoted post. A quote becomes a video. That loop accelerates belief. Human sympathy fuels it too. The voice sounded urgent and lonely. People love the idea of a single person carrying bad news from the future. Emotion trumps slow archival checks. Here are 3 simple verification steps you can use right now. 1. Look for independent records that sit outside the story community. 2. Check if predictions were specific and falsifiable. 3. Look for replication. If only one person claims a thing and no one else sees it, treat the claim as unverified. There is an important social point. Modern myth does not need disappearance to thrive. It needs a convincing voice and a community that wants to believe. That is why claims about vanished scientists deserve heavy skepticism before headline breathlessness. You close the tab. The cursor blinks on a midnight forum. Somewhere a fan edits a clip. The rumor keeps walking, even though the record sits quiet. Bruno Pontecorvo. You hear a rumor that a respected physicist simply walked off a bus and vanished. He was a brilliant experimentalist who worked on nuclear research. In 1950, he left his position in the West and surfaced months later in the Soviet Union. For decades, Western intelligence agencies speculated. Was he abducted? Did he defect for ideology? Did he carry secrets that changed the balance of power? The facts are quieter and more human. He had published important work on neutrinos. He continued to publish after the move. He built a life in a new country, and he raised a family. Declassified files and later interviews show a mix of motives. Some evidence suggests political sympathy. Some documents hint at secret approaches. But none of it proves anything like a discovery of time travel. So why does this case feed late-night theories? The answer starts with context. The Cold War was a time of secrecy and paranoia. Scientists working on nuclear and particle projects handled sensitive information. When one of them disappears, the imaginative gap is vast. People prefer dramatic explanations to bureaucratic ones. A secret defection becomes a story about stolen machines and shadow labs. There are also emotional currents. A person who changes side is easy to recast as a spy or as a prophet. That binary attracts storytellers. It also invites loyalty tests and conspiracy thinking. Here is a useful takeaway. Check the archives. Start with declassified reports. Look for published work after an event. If a scientist continued to publish, study, and mentor others, then the idea that he built a secret time machine becomes much less likely. If you found out today that a prominent researcher vanished, where would you look first? The train in the station takes off. The papers he left behind close like a book. Later, documents mattered more than the initial panic. Declassified reports released decades afterward give a clearer picture. Intelligence files show interest. They also show uncertainty. He was approached and questioned in ways that remain uncomfortable. The papers do not tell a tidy story of abduction or miracle. They show choices and pressures in a divided world. One strong fact is continuity. After the move, he continued to publish. He kept working on neutrinos and on problems others found important. Publications and conference records are public. They can be checked. When a scientist continues to publish and collaborate, it undercuts the idea that he vanished into secret experiments. That is a simple and powerful test. Another detail helps. Interviews conducted after files were released reveal motives that are human. Some were ideological, some were personal. The archival record often shows mixed motives. That ambiguity invites storymakers to prefer a single grand explanation. People like simple endings more than complicated lives. Here is a practical verification step you can use for any dramatic disappearance story. First, search the academic record for publications after the event. Second, check National Archives for declassified personnel files. Third, look for corroborating interviews with colleagues. If those elements exist, then the rumor that someone discovered a forbidden technology loses weight. What remains is the human cost, lives rearranged, families split, careers rerouted. The mystery becomes a folder in an archive. The headlines fade. The real life continues in footnotes and in the slow work of science. Stand on a snowy platform and watch a train pass. The luggage tags blur. The station clock keeps time. The papers close, and a name becomes something less mythical and more painfully ordinary. David Kelly. You picture a weathered lab notebook and a lonely footpath that leads out of a secure compound. He was a scientific advisor on biological weapons and a quiet expert who stepped into a furious public debate. In 2003, he became the center of a political storm over alleged weapons. A press leak and a public row followed. Weeks later, he died. The official inquiry found his death to be suicide. The Hutton report set out its reasoning in careful legal language. Medical reports, witness statements, and timeline evidence were examined. That official record matters, and yet conspiracies bloomed. Why did they start? The answer is partly human. He had access to sensitive knowledge. He had been pushed into the spotlight as a reluctant whistleblower. The stakes were national and emotional. Where there is secrecy and high drama, people reach for hidden explanations. A politician, an agency, a secret program becomes a tidy villain. That urge creates certainty where none exists. Here is what to hold on to. Official reports are not infallible. They are often imperfect. But they are documents you can read. They contain names, dates, and evidence. They provide a baseline to test sensational claims. When a story leaps from allegation to an assertion that a scientist was silenced for discovering impossible technology, ask for the documents that support that leap. There is another reason myths persist. Modern media churns faster than archives. A headline multiplies. Memory compresses nuance into narrative. Feeling fills the gaps that rigorous reporting leaves open. So when you hear that a scientist vanished because they found a door in time, ask a practical question. Which documents would prove it, and why have they not appeared? The path along the compound is wet with rain. Papers are slow and patient. Rumors run fast and loud. The official record is the thing you can read. Reports list times and places. Medical evidence is documented. Witness statements are recorded. Those materials form a benchmark. They do not answer every question. They do not erase pain. But they give you a way to check a story. When a sensational claim appears, ask for documents. Ask for dates. Ask for corroborating names. Look for work that continued after the event. Publications and conference records are public. If a researcher kept publishing, then the idea that they found some hidden machine becomes hard to believe. That is a simple practical test you can run in a few minutes. Why do conspiracies persist, even when records exist? One reason is emotion. Grief, anger, and fear make tidy villains attractive. Another reason is speed. A headline travels faster than an archive team can file a response. A third reason is narrative shape. Stories that resolve neatly are easier to share than messy facts. Here are 3 quick checks you can use on any dramatic disappearance claim. 1. Search academic databases for work after the event. 2. Search national archives for declassified files. 3. Look for independent reporting outside the community that first circulated the rumor. Those steps separate rumor from record. Finally, remember a human truth. Behind every dossier is a life. Families are affected. Careers are altered. The hunger for mysterious explanations often overlooks that reality. Stand at a quiet graveyard at dusk. The wind pushes the pages of a closed file. The headline glows on a screen far away. Which one will you trust when the lights go out?